Hello, everybody. It's a pleasure to be here, and I am so glad to see so many of you. You must have heard that I am not going to live up tonight to my sometime reputation as Dr. Doom. When I first started talking about the hazard of asteroid impacts nearly 20 years ago, I got that name because I was pointing out a hazard as if we needed another hazard, one that we didn't know about. Now I'm going to talk about, in fact, how we're dealing with that hazard with considerable success. In fact, in the 16 or 17 years I've been on this job, not one person has been killed by an asteroid. So it's my most successful activity. Well, what we're going to do is actually combine two things here, astrobiology and asteroid impacts. And that's not so hard to do because astrobiology is about the relationship between the cosmos and life. And one of the things that first drew our attention to impacts was the discovery that it was an asteroid impact that produced the mass extinction at the end of the Cretaceous period, did in the dinosaurs, had a profound change on the history of life on Earth. In fact, I can hardly think of a more direct way, other than sunlight, that the cosmos comes home and can affect the history of life on Earth. Let me start, though, just by reminding you that even though you haven't read about any recent major impacts, it does happen. We are coming up now on the 100th anniversary of the impact in Russia, in the Tunguska region of Siberia, which happened in June 1908, leveled about 2,000 square kilometers of forest, and has been estimated as the equivalent of a large 10 to 15 megaton city killer kind of explosion that was due to an asteroid, a fragment of an asteroid, if you will, roughly the size of this building, that came in over Siberia, exploded before it hit the ground, did all this damage, and first called humanity's attention to the fact that things could come hit us, that the sky could fall. It's still a weird thing, Tunguska. It's way out in the wilderness of Siberia. The original blast probably didn't kill anybody, and I think if it happened at the same place again, it still wouldn't kill anybody because it's really way out there. But the new capitalist Russia is making some use of it. This is straight from a website in which it talks about Tunguska blast as a powerful dietary supplement, which originates from the meteoritical events in 1908 in Tunguska, and that it created an oasis of fertility where herbs and plants grow and so forth. So if you want to, you can go on the web and look for Tunguska and find this place and order some of their wonderful dietary supplements. I don't recommend it, but you can. Well, the connection between impacts and extinctions is rather more profound because a mass extinction is just about the worst thing that can happen to us here on Earth. A mass extinction is defined as an event in which more than 50% of all species go extinct. Not 50% of living things are killed, but 50% of species go extinct, which means there's not a single survivor of that species. We may have had such events through much of Earth history, but the fossil record only really tells us about the last 560 million years. And in that period, there have been at least 5 big mass extinctions. What you see here, and I apologize for the fact that it's not very clear, but here are 2 ways of showing the data where people look at the fossils from the last 500 million years and estimate the number of species or families or genus. And in the first one, you see the number as a function of time, and this is only big creatures, at least the size of bugs. It doesn't count the microbes and the little things that don't leave fossils. And you can see it has ups and downs, and each one of these downs is a precipitous drop in the diversity of life, and this is just the other way around. This shows the rate of change, so each drop up there corresponds to a peak here when there is a very concentrated period of mass dying. And for a long time, it's been a real mystery as to what could produce that. There's obviously a background level of extinction and of new species being formed, But the idea of something catastrophic, and I do want to emphasize the catastrophic. No one knows in most cases how long it took for the extinction to take place, but I think you have to think in terms of years, not millions of years. Because if something changes gradually, sea level change, global warming, whatever, most species will adapt one way or another. To actually kill off more than half the species on Earth, it has to happen very quickly. So we're looking for events that are catastrophic. And the largest was the one 251 million years ago up here, when more than 90% of all species went extinct. And the most recent, and the one we certainly know the most about, is 65 million years ago at the end of the Cretaceous. That's this peak right here, which has always caught our imagination because it corresponds to the end of the dinosaurs. Well, this is a story that I'm sure most of you know at some level, so I will go through it rather quickly. But the discovery that the end Cretaceous mass extinction was due to an impact of an asteroid or comet is one of those revolutionary scientific discoveries. It suddenly gave us a whole different perspective on the dynamics of evolution. And part of what makes it so neat is it was all done in one paper. There's one paper published in 1980 in Science by the father and son, Louis and Walter Alvarez, and their co-investigators who are shown in the lower right, in which they didn't just discover and publish the data. They wrapped the whole story up. And very briefly, this is it. You have a cross-section here. This one is from Gubbio, Italy. But any place that you have marine sediment, that is sediments formed in the ocean, you can build up this, and it's just this time sequence. The lower things are older, the upper are more recent, and this is just one little bit of a huge cross-section that goes on for hundreds of meters or even kilometers. Why marine? Because that's just the way erosion works. Hardly anything is left on land because the land is constantly being washed into the sea. So the sediment builds up in the sea, and there you have the record. Now, what is interesting, of course, is what this material is. It's limestone. It's made of the fossils of little microscopic sea creatures. Incredible numbers. I mean, most of the material here is these little fossils. These little shells can be identified, and you can look at the population down below this boundary, and there's thousands of different species. And then you look above the boundary, and only 10% of those species made it through whatever happened here. This point of difference, and you can see it's just about the width of your finger. Something dramatic happened then that caused a 90% change in the species of these marine creatures. And there's no question about where it happened because, there are plenty of fossils. You just can look at a little thimbleful here and compare here, and you can see the difference. What these gentlemen and their team discovered was that there was the extraterrestrial metal iridium in this layer, and later a lot of other things as well. How many of you have a platinum ring? Platinum is valuable, right? Platinum and iridium are very closely related. They are valuable, not because they are scarce in a cosmic sense, but because almost all, 99+% of it on Earth, went into the core when the Earth differentiated.